see now, the first approach gives us the answer 500 and takes around 5.98 so on milliseconds, and the second approach takes 0.187 milliseconds. There is a drastic difference. Now let's see what different are we doing in approach second. Hey everyone, welcome back to our channel. I'm Yomesh Gupta. So this is the first part of a multi-part series where we'll talk about how to improve the performance of our JavaScript code. We are going to take a look at a couple of common scenarios plus some niche scenarios where we can use some tips and tricks to improve the performance of our code and decrease the memory usage. So without wasting any time, let's get started. So before diving into the code and the scenario, let me show you the output. Let us see that what kind of difference in performance are we getting. So let me run this file. I have this object shapes.js. So here you see that there are a bunch of console log statements. We have one dataset 1 and dataset 2, and we are doing some sort of filtering operation. We'll go dive into the code. For dataset 1, the execution time is coming out as 0.46 seconds, and for the dataset 2, the execution time is coming out as 1.45 milliseconds. So sorry, this is in milliseconds. Now for the same datasets, dataset 1 and dataset 2, the sorting operation, the execution time is coming out as 5.95 and so on milliseconds, and for the dataset 2, it's coming out to be 7.64 milliseconds. There is some decent amount of difference between the execution time. So now you must be wondering, what is the data set? Are they how different they are? What sort of operation we are performing? My idea here to first show you the output is to show you that with minor changes there could be a significant difference in the execution time. So let's deep dive into the code now. So let me just close this. So yeah, let's go over the data sets. So we have two data sets here. Each data set is an array of 10,000 objects, and inside that array there are each object contains an ID, name, price, and category property. Now category could be electronics or clothing, and like this there are 10,000 objects with different values. Okay, this is the data set 1. For dataset 2, we have the same keys, ID, name, price, category, which could be electronic or clothing. And out of 10,000 objects in the dataset 2, some contain a property called discount and others don't. The what distribution could be something like that. 5,000 contain the discount key, and rest and it's missing in the rest of them, or half contains the discount key and half don't. And we have two functions called filter products by category and sort products by price. So basically these if you see the console log statement, we are calling this filter products by category. We are passing consistent products, which is basically the data set 1, and we are passing a category. So we are filtering out all the products inside the products array where the category is matching here, which is right now the category is electronic. And same for the second operation where we are sorting all the products by price. And if you want to see the code, we are just generating the products here, that we are just putting the products in a array and returning it. So far so good. Now we saw that both the data sets are pretty similar, but the only difference between the two dataset was that the dataset 2, the objects in dataset 2, some contain the discount key and some don't. And just because of that additional key, we see the difference in performance. Now let's understand why is that. Why is this happening? So let's understand how JavaScript code or the JavaScript engine works on a very high level. I'm not going to go into too much in depth about this, but I'll explain you in a brief sense how this works. So we have our JavaScript source code, just like our object shapes, and we use the parser. The engine uses the parser and creates an abstract syntax tree. Now this abstract syntax tree goes to this cycle where we have interpreter, which interpreter converts the abstract syntax tree to bytecode. Now bytecode is an unoptimized version of your code, and this bytecode goes inside the optimizing compiler with some profiling data to further create the most optimized version of your code. Now this optimizing compiler using this for profiling data contains the more creates the most optimized version of your code as much as possible by the optimizing compiler. Now this is the cycle, journal cycle, now which is used in V8 or Node.js, Chrome, and but obviously there are minor differences like Firefox, I think Spider Monkey or Spider something is the name. That engine, there are a couple of steps here and there, or the optimization steps are a bit more in the JavaScript core used by Apple or the Chakra used by Microsoft or used to use by Microsoft. Now but overall the structure is this, that we have the source code, we parse it, we have the abstract syntax tree, from that we create the bytecode, and with this profiling data we send it to optimizing compiler and creates the optimized code. Now based on the profiling data collected here, optimizing compiler makes some assumptions, and based on those assumptions the optimized code is created. If any of the assumption is wrong, then the optimized code or from here we send back the optimized code, which we call de-optimize here, and this cycle repeats itself. That if the one of the assumption is wrong, then we generate or what we say rerun the cycle again. Let us understand that in our case what exactly is happening. So in our case we have products, and each product contains, let's talk about dataset 1. For dataset 1 we have id 1, name, price and category. We have 4 keys, and similarly for product 2 we have 4 keys. Now the JavaScript engine property access is the most frequent operation performed most of the time. So JavaScript engine tries to optimize whenever we let's say pass a object to a function. So JavaScript tries to optimize this behavior, and on a high level what it does is that based on the object we pass, it creates a something called shape. Now shape is a very generic term. In different engines it's used by with different names. Some call it hidden classes, some call it maps, and so on. You can search for these things. So but the general gist of it is that the engine creates a shape based on an object, and this shape contains all the keys present in that object. So the key here the keys are id, name, price and category. Now each key further links to another data where we have more information about that key. Is it writable, is it enumerable, it is configurable, and value and so on. But the thing here is that when a function runs multiple times, then it is called a hot function, and engines try to optimize that function. So based on an object, the engine creates a shape, and all the objects, it makes an assumption that if we are to a function, if we are passing an object, then all the subsequent inputs must have the same shape or similar shape. So or not even similar, like exact shape. So that's why they create a shape, and all the objects, so in our data set 1 all the object had the same key. So it creates the shape once and use it for all the data sets. There is only one creation, and it's not that simple exactly, because after creating a shape there is transition tree, there is inline caching, a lot of more stuff. But the high level understanding here is that for an object with with certain keys, engine creates a shape and with those keys, and all the similar exact objects or same type of objects will use that shape itself. And that's the assumption made by the optimizing compiler based on the profiling data. Now in our dataset 2 we had an additional key called discount. Now this discount was available for certain objects, was not available for rest of the objects. So the assumption made by the engine that all the objects would have the same shape is wrong. And as we talked about, that when the assumption made by the optimizing compiler is wrong, then we go back to the de-optimize cycle, and this entire cycle runs again. So that is why when certain objects had the key and certain objects are missing the keys, this cycle, this shape becomes invalid, and the engine needs to run this cycle again and again, and that is why you are seeing the performance difference. So coming back to the code, I'm not saying that you should, blindly follow this, and because obviously in real world scenario, when let's say we are calling filters or any method, then every time it's sometimes keys are always same. Sometimes, if you're getting data from backend or if you're doing some computation, then the keys are missing, or maybe there are one or two keys missing and so on. But the takeaway from here is that if you're invoking a function multiple times, it's a hot function, then try to keep the input objects same. They should have the exact keys, so that the order of keys also matter in this scenario. You can't, just move the keys up and down, because for the JavaScript engine, it creates a shape based on the keys present and the order of keys. So that's why try to keep the keys inside an object same, or their order and the number of keys. And this is not just, limited to your vanilla JavaScript. I'll show you one example. So let's say this is React code. Okay, now in React we have a component called products, and we have a products array where we have id1, title, description, price, and discount, and all the objects are same, all the products are same, they have the same key. So what we are doing is we map over the products array, and we render a product card, we pass a key, and we just spread out the product object here. And inside the product card, we expect title, description, price, and we are rendering all the markup here. It sounds good, it is okay, but this also creates a problem for the engine, that it can invalidate the shape, because we are passing an additional key called discount to the product card, but it is not accepting or expecting that key here, it is not using it. So the engine, for engine, this shape is invalidated again and again. So that's why, people tell you many times that you should pass your you should pass the props that are required, those props only to your components. You should not, just blindly spread and pass all the objects. So that's also one, that's why one reason people tell you that. Obviously I'm not telling you that, you just go back to your code and start deleting it, start refactoring it. Obviously premature optimization is as bad as doing no optimization. So try to measure your code, see if there is a bottleneck, see if there are performance issues, and then. So we talked about how shapes play a role in property access in JavaScript, and how V8 engine tries to optimize the shapes and hot functions, and how it affects the performance of our JavaScript code. So like dataset 1, we had objects with all the same keys in the same order, and for dataset 2 we had the same keys but additional key discount for 50% of the objects. Now what if we add like the default value for discount? We would still be modifying it, but there is a default value. So now if I run the object shapes, then the performance is almost similar now. Earlier, there was a drastic difference, but now it's similar because the shape for the inconsistent or the dataset 2 uh, would be reusable and would be created just once by the engine. So the changes we saw are just not limited to the simple example I showed you. If you go out in the wild and search for it, like in the React repo, the React library repo, there was a PR where someone mentioned that these objects had similar keys or the same keys but in different orders, like type of consumer provider, and consumer provider is mentioned here at the bottom. The order of the keys are different, and uh, issue mentioned that how these changes are triggering the de-optimization cycle in V8, and how we can avoid this. So there are bunch of issues, and mentioned, if you go and check the pull request and issues in React or React Devtools, and if you see your code also, there must be a lot of low hanging fruits that you can do and achieve. And also, having said that, you have to measure first that is this valuable enough, is the the changes made or the tip and tricks I am telling you is even worth it in your code base. You have to definitely measure, and because pre-mature optimization is worse than no optimization at times, so be mindful of that. So the next topic we are going to talk about is data structures. We're not going to go in depth in every data structure, but we are going to take a fisheye view of data or data structure or a particular scenario in the front end domain. Oftentimes it comes in the conversation that should I even bother with DSA when it comes to front end? How much DSA is enough for front end? And a lot of people come up with this answer that DSA is not required that much, we should not do DSA, or we should just focus on development or frameworks and so on. That is good, you are focusing on development framework, that is good, but DSA, logical thinking and problem solving is the core fundamental of any engineering discipline, so that's important. First, second, it is important to know that what type of data structures and algorithms to use in which scenario, because in front end also we access data, we iterate over data, we do searching, so it's important to know the fundamentals. Now let's see this case. In this case we have user IDs and admin IDs. Let's say we have 500 admins and 1000 users. Now we have to tell the count of users that are admin. Okay, so let's see the first code. In this, what we do here is that let's say we have the admin ID array like 1 2 3 and so on. In this we use includes and we check that if particular user ID is present inside the admin ID array. If yes, then we'll increase the counter, and after that we'll print the counter and the time taken by this code. Now if I run this now, to just to show you the difference between first approach and second approach, I'll show you the output first. So if I see now, the first approach gives us the answer 500 and takes around 5.98 so on milliseconds, and the second approach takes 0.187 milliseconds. There is a drastic difference. Now let's see what different are we doing in approach second. So in approach 2 we have the same code, but in place of the admins array we are using a set, and inside set we are checking that if the particular user ID is present in the set. Now this is an order of n because inside the inside, so this is order of n, this particular loop, then this is also order of m, because in this we are in this array we are checking every element till we reach the particular element of the user ID. But in this case this is order of 1 because admin IDs is a set, so that's why it's a difference. And uh, we see the drastic difference in the runtime here, execution time basically. So it's important, we always fall back to arrays and objects, which is good, but there are other data structures in JavaScript like sets, weak maps, or weak sets and so on. So it's important to know those. It's important to understand that if a particular algorithm or a particular data structure is more suited for my use case, is it more performant, so these things are also matter. And plus I'll show you one more thing, that it also matters which method or which function are you using. Let's say in place of includes, if I use index of, and if I say that if it's not -1, that is we find the user ID in the admin ID's array, and if I run this now, then see the difference, that earlier it was taking almost 6 seconds, now it's 3.6. So it is almost roughly 40-50% of gain in performance or reduction in execution time. Let's run it a couple of times to see if it's actually consistent or just a fluke. Again 3.65, again 3.82, so it's consistent that a single change from includes to index of is reducing the execution time by 50%. Now it's up to you to figure out why this is happening, and why in place of includes if we use index of, then we are getting a 50% reduction in execution time, and share your reasoning in the comments. So now this third topic is a bit subjective, controversial, and it's somehow depends on preference also. So here we have array methods, and like we are solving something using array methods, higher order functions. Then we have an iterative approach, and then we have again array methods but written in a different way. Let's first talk about what's happening here. So let me zoom in a bit more. So here we have a array of numbers, like 10,000 numbers, and inside this we are first mapping and rounding off the numbers, then we are filtering all the even numbers, and then we are doing some summation. Similarly, in the iterative approach, we are doing the same thing. It's just that we have a for loop, and inside the better array methods, we are doing the same thing. But the difference here is that here we are using first map, filter, and reduce. Now in the better array methods, we are using just one reduce here and doing all the computation. So let's run this and see what's the output. So if I this currently it's running and these two are pending, so we'll wait for a while, and this is completed now. So this is almost done. The second one is also, and this is also completed. Let's see the third one. Now the third one is also done. So if we see the results, the iterative approach is the fastest, the better array methods is comparatively slower, and this is the least one. This is the slowest array methods. Now, like I mentioned, that my aim to show you this is to show the different approaches and the difference in performance. Obviously, when it comes to user experience, not user experience, when it comes to user experience in terms of developer experience, when it comes to developer experience or it readability, then the first method is preferred by a lot of people, which is good. But it really depends on use case to use case. If you are in a team building UI where you have multiple people working along with you, then I prefer higher order functions, because sometimes performance is negligible and readability and developer experience matters the most. So in that case also I'll prefer over method 1, I'll prefer method 3, which where we are using one reduce and doing everything here, because this is the slowest, because we are running 3 loops and each loop is making its own copy, so it will take more memory. Here we are just running one reduce and we are doing everything inside this, so comparatively faster and less memory consumption, and here we are not using any additional memory, so it's the fastest with lowest memory consumption. If we run it again to just to verify that is it still the fastest or is it a fluke or a consistent pattern. So this one is done. This we are running the second one, the 100 samples, and now we are the third one, running the third one. It's almost done. it, so the output is still consistent. This is the fastest, this is the comparatively slower second one, and this is the third one. Like I mentioned that this is a bit subjective. When I solve questions on Devtools, then I often resort to for loop when I solve questions for recursion or some problem solving questions. But when I'm working in an organization or when I'm working with a team, then readability and developer experience, these things matter a lot. So at that time I often go for like a something which is performant enough and readable enough. So third approach seems good enough to me. We are running a reduce function, so it's totally dependent on you. My approach, like I mentioned here, is just to show you different options, to give you exposure to different options and showcase the performance of those uh, uh, snippets, and it's now up to you to decide. So this brings end to our video. I hope you were able to learn something new today. If you feel that I missed out on something or I was wrong somewhere, then please do mention in the comments. Do reach out to me on social media platform. Also, there are links on the screen if you want to have one-on-one sessions with me, talk about your career or ask me questions, bounce around ideas or journal chit chat, maybe prepare for interviews. Then you can book a top bit session with me. If you just want to practice on DevTools, like a random, you don't know where to start, you can use devtools.tech/practice to start a practice question. And as always, do like, share, and subscribe if you see value in my content. Help me, like, help me raise awareness around the content so that more people can be benefited with this. It motivates me to do more. So, till next time, see you, take care, bye bye.